Lecture 4. In this lecture we will cover memory organization in 8051 microcontroller. This is the part of chapter 1. Myself Dr. Faiz Ahmad Kurne. Let's begin. The microcontroller has both ROM and RAM on the same chip. The program memory is used for storing only program to be executed. Therefore, ROM is also called as program memory or code memory. The data memory, on the other hand, is used for storing temporary variable data and intermediate result. Hence, RAM is also called as data memory. The 8051 has both internal ROM and internal RAM. If the internal memory is not sufficient, you can add external memory using suitable circuit. The 8051 microcontroller has 120 byte internal RAM and 4 kilobyte internal ROM. If we want extra ROM, we can add externally along with this 4 kilobyte internal ROM. Now, what is internal ROM? Any program is burned in the ROM. Program is fixed and cannot be changed, while internal RAM saves data temporarily, that is generated during execution time, and this data can be changed. Whenever the system is switched off, that means 8051 is power down, the data will be vanished. In 8051 microcontroller, the code, or we can say instructions to be executed, are always stored in program memory, that is ROM of the 8051, and it is 4 kilobyte of internal ROM. 8031 or 8032 does not have internal ROM, so we must interface with external ROM with instructions loaded in it. RAM in 8051 is also called as data memory. It is 120 byte and we can add extra. So this 8051 supports maximum 64 kilobyte of external RAM. This RAM is divided in 3 parts. One part is for 4 register banks: bank 0, bank 1, bank 2 and bank 3. 16 bytes are bit addressable and 80 bytes of RAM are treated as general purpose area or scratch pad memory. So you can see here the internal RAM has 3 parts. One part is 4 register bank, second is 16 byte as a bit addressable area, 80 bytes as GPR. So you can see here, this is what our RAM, 128 byte, out of which these many bytes, that means 32 bytes, 8 plus 8 plus 8 plus 8 are used for bank, 16 bytes are used for bit addressable, and remaining 80 bytes are used as a scratch pad. The banks are named as bank 0, bank 1, bank 3, and each bank consists of 8 registers named as R0 to R7. So we can say bank 0 with name R0 to R7, bank 1 with name R0 to R7, Same with bank 2, bank 3, but they have different address. So bank 0 is having address 0, 0, 1, 0, 2 up to 0, 7. After 7, bank 1 start 8 to F. After 8, bank 3 start, that is from 10 to 17, and then after 17, bank 3 will start from address 18H up to 1FH. So in this way, first 4 banks are in the RAM. So we can call this bank either by their name or address. So to address them by name, first corresponding bank must be selected. So we want to access R0 of bank 0, or R0 of bank 1, or R0 of bank 2, or bank 3. That is decided by RS0 and RS1 bit of program status word register. This is what the format for RS1, RS0. Now we'll see the next. If you want to call them by their address, then no issue. Each will have a unique address. So when we say 12H, so it will be 12H in the bank. So there is no, see here only one is 12H. So we don't have to specify it is R2 of bank 2. We are calling them by their unique address 12. So it will access R2. If we say address 0A, it will access R2 but of bank 1 automatically. If I want to access by their name, then I have to decide which bank. So calling by address will be very easy. Then next 16 bits are called as addressable memory location, and remaining are GPR. So remaining 80 bytes are used as GPR, and their hex address is 30H to 7FH. Thank you. If any doubts, please feel free to ask the questions on the mail given below.